This is 8.7. We are going to graph radical functions and apply the transformations that we learned earlier this school year on reflecting, transforming left and right, up and down. So let's start off with our first function. This is called the parent function. We are going to graph the function y equals the square root of x. Do write this slide down in your notes. So I'm going to just start off with graphing and finding some ordered pairs using an XY chart. So we're going to substitute different values in for x. So I'm going to just start with the number 1. So my domain is 1. I'm substituting numbers in for x. So if I take my calculator and I enter in the square root of 1 into my calculator, I get 1. So then the ordered pair is 1, 1. Now if I substitute 2 in, so I enter into my calculator the square root of 2, and I get approximately, it's not going to be a whole number anymore, so if you want to take a minute and try it with your calculator, the square root of 2, which is approximately 1.4, so the ordered pair then would be over 2, 1.4. And let's just do 3. Square root of 3. So again, with your calculator, you get approximately 1.7. So over 3, 1.7. Now let's go to 4. Square root of 4 is 2. So we have ordered pair 4, 2. I'm going to jump ahead to 9. And you'll see why in just a moment. The square root of 9 is 3. So anything between 4 and 9 is a decimal place of 2 point something. So if we look at these important numbers, just things that are whole numbers, 1, 4, and 9 give us nice, pretty ordered pairs to graph. So let's graph this now. Over 1, up 1. So here's 1 and 1. And then over 4, and then up 2, and then over 9, up 3. So that's what we have so far. Now let's talk about 0. If I substitute 0 in, so square root of 0, I get 0. So here it is. Now, please take out your calculators if you haven't done so already. Let's put in a negative into our calculator. So the square root of negative 1. If you plug in the square root of negative 1, you're going to get some kind of error message, either error domain or does not exist. The reason why it's outside the domain, you cannot have a negative square root of a number. So anything like -2, -3, -4, -5 does not exist. So how this graph is going to look is like this. It's going to start at 0, 0, and it's going to work our way to the right and just continue increasing a little bit over time. So in each of your homework problems, we do want you to identify the domain and the range. The domain is what can you plug in for x. So if we think back to our XY chart, could you plug in negative numbers? No. Could you plug in 0? Yes, we got 0, 0. So how we say this for the domain is x can be greater than or equal to 0. The next piece is the range. What type of numbers can you get out? So now we're looking at the y-axis. If we look at the y-axis, here's our y, or that's our y-axis. That's our y-axis. What kind of numbers can we get in these two places? So here's x, here's y. We're looking for numbers also greater than or equal to 0. So anything above the 0 line here is y 0. Anything above that. All right. On page 620 talks about all the transformations that exist with the at the square root function. We also talked about in lesson 2.6, if you want to refer back to your notes, that'll help you also. All right, so what we've done so far is just graphed the parent function. We don't want you to sit there and keep graphing all of those ordered pairs. We're going to highlight some key points instead and then apply the transformations. So what I'm going to do first is just graph the parent function again, f of x equals the square root of x. And I'm just going to focus on a few key ordered pairs. So this is the parent function, x and y. So remember when we substituted 0 in for x, we got 0. When we substituted 1 in for x, we got 1. We substituted 4 in for x, and we got 2. I'm just going to focus on those three ordered pairs and graph it in the blue. So over 0, 0, up 1, 1, over 4, up 2. So there is our blue parent function. What we want to do is graph the function the square root of x minus 3. So we have to be careful of what is the change from the original parent function. So think about this minus 3. We call it inside the function. So what happens is we're going to horizontally shift it right 3. These are what we call inside the function. We have to think opposite. So we're going to take each of these ordered pairs in the blue and shift them to the right. So this original will now be called g of x, the square root of x minus 3. If this is my x and my y, which of those ordered pairs is going to change? Is it going to be the x values or the y values? Well, it's going to be the x values. So this original 0, 0 is going to shift 3 places to the right. It'll end up right here. So this will be 3, 0. I'm just going to put it over here. Then the next ordered pair is going to shift 3 to the right. So now it'll be 4, 1. And then the next one, 4, 2, will be shifting 3 to the right. So that will be 7, 2. So over 4, up 1, over 7, up 2. Then we have to talk about the domain and the range. The domain is a little different now. The domain is what can you plug in for x. So I'm going to just create a vertical line here so you can start to see the domain. If I enter in anything less than 3, it doesn't show up on my graph. It's out of the domain. So my domain has to be, x has to be greater than or equal to 3. Then my range hasn't changed at all. That's still just, if I graph this imaginary dotted line, anything above this line exists. So my range then is y is greater than or equal to 0. Here's another example. This one you can just watch. So we graphed that parent function. Hopefully we're getting that parent function memorized. F of x equals the square root of x. Again, you're not writing this down. And we have those ordered pairs 0, 0, 1, 1, 4, 2. So we graph it. Now, what happens when we go plus 1 inside the function? Well, that's going to shift it left 1. So we're going to pick up this blue ordered pair set, shift it 1 left. So there is our function. Now what's the domain? The domain is anything greater than or equal to -1. Here's -1. Anything to the right of that green line is the domain, so greater than or equal to -1. And the y values have still not changed, haven't moved along the y-axis, so the range is still y greater than or equal to 0.